This is exercise 6.13, volume. The first thing we're going to do is metric units for volume. Now, we've already looked at metric units or conversions for length and area, and volume is very, very similar. So what I'm going to do, volume is a 3D shape basically. It's when you're in 3 dimensions. So for example, if I draw up a little, do you remember those little 1 centimetre cubes at primary school? Obviously a lot smaller than this, but do you remember them? The little, well, so if I've got a 1 centimetre cube, it's 1 centimetre times 1 centimetre times 1 centimetre. That is identical to drawing another 1 centimetre cube, but instead of writing 1 centimetre, 1 centimetre, 1 centimetre, 1 centimetre is how many millimetres? 10 millimetres, 10 millimetres, 10 millimetres. Now these cubes are identical. Let's look at the volume of the first cube. I mean, they're the same cube, but we're just doing volume in the different units. Notice to draw this, I drew a square, and then I go back, back, back. Or some of you can draw it like this. Square, another square, overlapping, and join the corners. Whatever you like. The volume of the first cube is, remember how it's length times breadth times height? L times B times H, which is 1 centimetre times 1 centimetre times 1 centimetre. What's 1 times 1 times 1? 1. Centimetres times centimetres times centimetres is a centimetre cubed. Now, that cube on the left is the same as this cube on the right. The volume of this cube will be length times breadth times height, which is 10 millimetres times 10 millimetres times 10 millimetres. What's 10 times 10 times 10? 1,000. And the units are millimetres cubed. So what we've got is that 1 centimetre cubed is 1,000 millimetres cubed. Now, I don't learn them like that. What I've got here is a little table showing you length units, area units, volume units. Because we know that length, they're just normal units, linear units. 1 centimetre is 10 millimetres. Area, 1 centimetre squared, you're squaring that. 1 centimetre times 1 centimetre, you're squaring this as well. So if you do 10, see we've got millimetres squared. What's 10 squared, girls? Do you want me to write here that it's 10? It's 100. Do you notice I've done 10 times 10? Double? You're doing double. And what do you think this one is? 10 times 10 times 10, because you're doing it 3 times. So it's 1,000. Does that make sense? The length one has 1 0. The area one is squared units, so it's 10 times 10 is 100. The volume one is cubic units, so it's 10 times 10 times 10 is 1,000. So if you just learn the first one, when you're squaring everything. 1 squared is 1, centimetre squared is centimetre squared, 10 squared is 100, millimetre squared is millimetre squared. If you're doing volume, you're cubing everything from the original one. 1 cubed is 1. Centimetres cubed is centimetres cubed. 10 cubed is 1,000. Millimetres have been cubed as well. So looking at this one, if 1 metre is 100 centimetres, what's 1 metre squared? 100 times 100. 100 times 100. Do you get that? You're doubling the zeros. In other words, you're doubling the zeros for area and you're tripling the zeros for volume. And it just makes so much sense because area is always squared units and volume is always cubic units. So if we triple the zeros, normally it's 100. Normally 1 metre is 100 centimetres, but it's cubed, so you're tripling a number of zeros. Does that make sense? You're doing the conversion 3 times, in other words. With area, you go 100 and another 100. You're doing the conversion twice. Does this make sense? Yeah. All right, if you know, so all you need to know is the normal length units. 1 kilometre is 1,000 metres. So if squared, I do it twice. 1,000 and another 1,000. Get it? Yeah. And how many zeros for the metres cubed? 1,000 once, 1,000 twice, 1,000 3 times. A billion. So with area units, you do the conversion twice. For example, if you're meant to divide by 100, for example, you do it twice. You divide by 100 and divide by 100 again. With volume, you do the conversion 3 times. For example, if you're supposed to times by 100, you times by 100 3 times. So we're just going to do an example of a conversion. Can we convert, let's go 75 meters cubed to centimeters cubed? And another example, let's convert 5,200 millimeters cubed to centimeters cubed. Okay, we're going to do 2 examples with unit conversions. 75 meters cubed to centimeters cubed. Don't worry about the cube. Just think, how do I go from meters to centimeters? Don't you? So times 100 times 100. I don't mind if you write times 100 times 100 times 100. Or you go 100 has 2 zeros. I need to triple the number of zeros. What would you like to do? So 2 zeros, 4 zeros, 6 zeros. The only problem with that is don't mess it up as you put it into your calculator. I'm really happy for you, or you can go 75 times 100 once, twice, 3 times. That's fine too. Either that or that. Do you get it? So you could do it either way, and let's just, it's a whole number, so we'll just add 1, 2, 3, 4, 5, 6, 75 million centimeters cubed. Okay? So therefore 75 meters cubed is 75 million meters cubed. The next one, 5,200 millimeters cubed, centimeters cubed. Just think to yourself, how do I go from millimeters to centimeters? Small to big.
Divide by 10.
Good. And how many times do I divide by 10?
3 times.
So either you go once, twice, 3 times. Do you get it? Or you could go 5,200 divide by 10, divide by 10, divide by 10. 3 times. And the answer we get is 5.2 centimeters cubed. Now, the formulas for volumes. The first shape we'll look at is any sort of prism. It does not have to be a rectangular prism like this one. For example, I can have a prism that looks like this. Watch what I'm drawing here. For example, if I've got a trapezium, and if I draw another trapezium behind it, that's a trapezoidal prism. That's another example of a prism. Now, when you work out the volume of a prism, you have to see which shape stays the same if you continuously cut that shape. That's called the uniform cross-section. If I look at this shape over here, and if I say shade the front of it, and if I kept, it's like a loaf of bread. If I kept cutting like that where I've shaded, keep going back here, would I get the same shape every single time?
Yeah.
If I get the same shape every single time, that's the uniform cross-section. We find the area of that, and then how far back it goes is what we call the height of the prism. The height of the prism is not the vertical height, it's just how far does that shape go back. Remember, I can turn that prism on its side if I want. I can turn it, provided the uniform cross-section's on the bottom. Let's say I tip it over to have the uniform shape on the bottom, then it is the height. But the height is how far does that same shape go back. Does it make sense? With this prism, this rectangular prism, I could have shaded the front, the bottom, or the side. It's because that's like a loaf of bread. It doesn't matter which way you cut a rectangular prism. So you can call any of them. Normally with the rectangular prism, we just go length times breadth times height. Do you remember that?
Yeah.
All right, but something like this type of prism, there was another type of prism, would be a triangular prism. One triangle, another triangle behind it. Girls. Okay, I have a triangular prism. Which one is the uniform cross-section? What sort of thing do you think of when you see that? A Toblerone sort of thing. Right, so it's called a trapezoidal prism. The uniform cross-section is the trapezium. How far back does it go? This is a triangular prism. If I cut, say, this sideways, I won't get the same shape. But if I cut down like that through all the triangles, I get the same size triangle every single time. That front face is the area of my cross-section, and H is how far back I cut. They don't call a cylinder a prism because prisms have straight edges, but a cylinder is a type of prism. If you have a can like that, if you keep cutting through like that, you get the same size circle every time. But if you were to cut up and down, you'd get different size shapes all the time. So this shaded bit at the bottom is your cross-section. So even though the volume is area of that times height, what's the formula for area of a circle? So it's pi r squared times h, or pi r squared h. Does that make sense? Yeah. A circle is the same as a prism. What's the uniform bit? What's the shape that never changes? Circle, how high back? So if I kept cutting the circle, this cylinder, how far I cut or I can cut is the height. The last one is the pyramid. Now, with the pyramid, you will be given the formula. It's the area of the base. They've done the area of the base times the height, but it's 1/3. The reason is the volume of a pyramid is 1/3 times the area of whatever the base is times the perpendicular height, which is the straight up and down height from the middle, not the sides, not the height of the sides of the prism. The perpendicular height, the straight up and down height. Okay? So volume is 1/3 times the area of the base times the perpendicular height. This is, can you see what the uniform cross-section is? It's the trapezium. So let's do the area of the trapezium. What's the formula for the area of a trapezium? No, it's no surface area. I want volume. See, this is the trapezium. I want the area of this. This is 18. That's 8. What's this? Yeah, but what's this? Good. So, what's the area of this? What's the formula? A plus B over 2 times H. What's your A and B? 15 plus 18 over 2 times 8. Well, 15 and 18 is 33 over 2. That's 16.5 times 8. You'll have to tell me what that is. In brackets. I should have picked a nicer number. Can I change one of those numbers? Oh, what is it exactly? 132? What would be if this is all centimetres, that's just area. What are the units of area? Squared. Centimetres squared. But what's the formula for the volume of this shape? Yeah, but I do the area of that times the height of the prism. Which one is the height of the prism? So there's my uniform cross-section. I'm actually going to shade it. No. That's my uniform cross-section. Yeah. If I kept cutting that shape, that's my uniform shape. If I kept cutting that shape, how far back does that go? That's your H, is the 23. Now notice this is centimetres squared times centimetres. Centimetres squared times centimetres is centimetres what? Cubed. But someone needs to tell me what 132 times 23 is. Always 2 steps. This is a prism. You understand why it's a prism and not a pyramid, this one, don't you? All right, because it's got a uniform cross-section. Volume of any prism is area of the cross-section times the height. How far back does it go is the height. First step is to find the area of the uniform cross-section, shape that never changes. Work that out and multiply by how far back it goes. Now, we're going to do the next shape. What type of shape do you think that is? A triangular prism. First thing you want to do is the area of the triangle. I've drawn the triangle there on its own. Good. So the area of a triangle is a half times the base times height, which is a half of 10 times 1.5, 7.5 centimetres squared. But that's the area of this shape. That is not the volume. Then we times by how far back those triangles go. That's the height. So the volume of the prism is A times H, which is 7.5 centimetres squared times 12 centimetres. And 7.5 times 12, is it 90? It is. 90 centimetres cubed. Let's say that the diameter of the outer roll is 20 centimetres and the diameter in the middle is 10, let's just go 8 centimetres. Okay, shh. We're trying to find the volume. You can do this two ways. You can do the volume of the big cylinder minus the volume of the small one, but see that ring shape? Isn't that the same? If I keep cutting down, would I get the same shape every single time? So what I'm going to do, I'm going to do the area of this first. And then I'm going to times by how long this is. Let's go 30 centimetres. Okay? So, the top of this, because that's the uniform cross section, can you tell me what the radius of the small circle is? So, isn't it the big circle minus the small circle? Actually, that's the diameter of the small circle. What's the radius of the small circle? Good. And if the diameter of the big circle is 20, what's the radius of the big circle? 10. Sorry, that's a 10, girls. Looks a bit small. So, if you want the area of that ring, isn't it the big circle, take out the little circle? So it's pi r squared, which is pi times 10 squared minus pi times what? 4 squared. Do we get that?
Yes.
Isn't that 100 times pi minus 16 times pi? Yes? Which is, what's 100 minus 16? 84 pi. I mean, you can work it out on your calculator, but you're going to have to write down all these decimal places and use it in the next step. The next step is the volume of this prism, which is area of this cylinder with a hole. It's area of this uniform cross-section times how long the cylinder is. So it's going to be 84 pi times 30, because that's the height. And now you can put that in your calculator. Look, girls, if you want, you can work this out to so many decimal places. It would be almost 300 if you did. But this way you don't have to carry all the decimal places. Anyone got an answer? What do we get? 84 pi times 30. Three. What I might just do is make that to the whole number centimetres cubed. All right, so that's but you know what? What if I asked you, actually this is a good question to do this in. I want you to change this now to metres cubed. That answer is in centimetres cubed. I want it in metres cubed. Now, what's the units of conversion from centimetres to metres? Divide by 100. How many times? 3. So 665,012 divided by 100, 100, and 100. You got it? Yep. Which is 0.665 metres cubed. So if you were, for example, in building or something like that, no one would walk around saying that's 665,000 centimetres cubed. That centimetres cubed there, I just decided that I would convert to meters cubed. All right? Because that's such a big number. But look, sometimes they might say, give the answer in meters cubed. All right? Now, I'll just set some homework